So today I'm going to discuss about hybrid-based recommender system. So there are some uh, methodology that we are going to learn. The first, yeah, we are going to learn what is hybrid. Yeah, hybrid means combination. And in combination-based recommendation system, there are three things that we will learn. The first is the monolithic hybridization. The second one is parallelized hybridization and pipeline hybridization. And yeah, in each of this method, you will see what are the approaches like feature combination, feature augmentation. And in the parallelized, we will learn about weighting, switching, and mix. And for the pipeline hybridization, we will learn about cascade and meta level. Okay, let's take a look one by one. We say hybrid. Hybrid means combination. So hybrid means combination of various inputs and or composition of different mechanism. We know that the input for the recommender system can be anything. For example, we can have rating. So rating means we know about the community data. So people give rating 5, people give rating 3, and so on. Or we can also get some user profile. Who are the users? Or sometimes we also see the contextual parameters. So where is the users? When the user give the rating, when the user watch the movie, and etc. And we can also have the product features. The product features, for example, the movie. So who are the actors? What is the genre? Who are the producers, and etc. And sometimes we also need the knowledge. So next week we will learn about the knowledge model. So today I'm going to discuss what is hybrid. So hybrid means we combine all this one, whether it is the input or whether it is the mechanism, into one component. So the component means, this is the hybrid component. It can be the collaborative filtering, or it can be the content-based filtering, or we can also use the knowledge base. So we're going to look at this knowledge base later, next week. And once we combine it, we will give the recommendation list. So this is the mechanism. So the idea is to crossing two or more species or implementations. So this is from the word hybrida. It denotes an object made by combining two different elements. Why we need this one? It is to avoid some of the shortcomings. Shortcoming means the weakness. So let's say when we use the collaborative filtering, what is the weakness? We just rely on the rate. We just rely on the numbers. If we do with the content-based filtering, what is the weakness? We just rely on the content. We just rely on the reading. And most probably it is on the qualitative. So we can combine the collaborative and content-based. And with this hybrid, we can reach desirable properties that not present in parent individuals. or sometimes maybe the result is inconsistent. If we use only collaborative, maybe the result is inconsistent. So we can use also the content base and so on. So different hybridization strategies, we can use the parallel. Parallel means, if we do the recommender system, then parallel, we can split the first and the second one at the same time. Monolithic. Monolithic means just try to explore, or exploiting different features. So we can take a look later, the feature combination or feature augmentation. Pipeline. So pipeline means we are going to look at one method and then we combine with another method and we combine with another method in the sequence. So we will take a look each of them. Monolithic hybridization, parallelized hybridization with those methods, and pipeline hybridization with those methods. First, let's look at the monolithic hybridization. There are two methods, feature combination and feature augmentation. In the monolithic hybridization design, we are going to have a single recommendation component. So means we have the input and then we go to the hybrid recommender. And in the hybrid recommender, we will see the first strategy, the second strategy, the third strategy until end strategy. And then after we have several strategy, we will show the output. So hybridization is virtual in the sense that features or knowledge sources of different paradigms are combined. So we just combine the features. This is the most common approach or the easiest one. So let's take a look about the feature combination. What does it mean by feature combination? The feature combination means we want to combine several knowledge sources. In this case, ratings and users demographics for similarity measurement. User demographic. This is, for example, the users age. Okay, so we call this is demographic, or users gender, male, female, or maybe users location. So we can see the demographic of the users, and we want to check whether those demographic affect the rating. And we can see the similarity. If the demographic is similar, then we can have a high certainty about the rating. We call this is explicit requirements and needs for the similarity computation. So if we have those data, of course, it is easy to do the feature combination. And this kind of features, or we call hybrid content features, are available. For example, in the social features. In the social features, like in the social media, okay, when you use TikTok or you use the Instagram, you can see there are some similarities on the user demographic. For example, movie liked by the user, or content. So comedies liked by the user, drama liked by the user, and then we want to do the hybrid. So we want to find user likes many movie, there are comedies. Then, okay, if the users like comedies, we can combine or we can group the users who like comedies, and we can take a look the profile, who are the users, it's whether they are male or female, and where are the location, and then we can combine with the content, and we can do the recommendation. So the common knowledge engineering effort that involves inventing good features to enable successful learning. So we call this is the common knowledge engineering or the common feature engineering. We combine those features. So for example, we can have the community knowledge and product knowledge. So the community knowledge means I have the information about users who buy which items. So for example, one, in this case, Alice bought item two. Here, Alice bought item four. So I want to know, yeah, I want to recommend which item that Alice will buy in the future. So let's say I have the product knowledge. Item one, the item one, the genre is romance. Item two, the genre is mystery, and so on. And based on this information, now there is a question. Which user are similar to Alice? Okay, so this is also the question in the exam. If you have this data, what will you do for the similarity checking? Okay, so we can say the person who buy similar items with Alice, it is the most similar. But in fact, we have another information, which is the genre. Let's say I want to recommend item 5 to Alice. Okay. But item 5 is fiction. Meanwhile, item 4 is mystery. And item 2 is mystery. Alice like the mystery, maybe this is book. Okay? Alice like mystery book. But can we recommend fiction book to Alice? So this is something question. Yeah, in the exam, I think most of you answer the problem using chakra and dice. So what is the reason to use chakra and dice? Chakra similarly, dice similarly. So first, we use this chakra and dice to represent the similarity because of the sparsity. The sparsity effect, yeah, we can try to reduce it using the chakra or the dice or the cosine similarity. And of course, you can use other kind of method like person similarity. However, the person similarity is not highly recommended because person similarity relies on average. Okay, if you still remember, when you use the person similarity, we will subtract the rating with the average of the rating. If you have only one product, let's say user 4, then the rating or the average rating will be biased. That's why it is good to measure the similarity using chakra or dice or cosine because they don't rely on the average. If you use the person similarity, you rely on the average, which is bias. Okay. So in the pure collaborative approach, without considering any product features, both user one and user two will be judged as being equally similar to Alice. Okay, let's see. User one, user two, we have one. Okay, we have one, we have one. It seems they are similar. Item two is about mystery. Okay, mystery, mystery. But if you look at the other item, user one bought item three, which is mystery, and user one also bought the item five, which is fiction. Meanwhile, user two is more diverse. User two bought item two, which is about mystery. User two also bought item one, which is about romance, and he or she also bought the item about fiction. So there are three different genres. And we can check the feature combination approach. So when we try to do the feature combination, means we need to identify the new features based on this community and the product knowledge. So this is the community data and this is the product knowledge data. So this is how we can do the feature combination. First, we need to do the feature setting. We set the user characteristics. For example, user likes many X book. So we define many. So many means, for example, if a user bought mainly books of genre X, or we can say 2/3 of the total purchases, or at least two books. 2/3. So it means two among three books. Okay, or maybe the percentage is 0.66 from the total purchase. They are in the category of X. For example, X is romance. So if romance is 0.66% among the total products, then we can say it is many. Or because this is a small data, so at least two books. So if the user one, let's say he bought item two, mystery, item three, mystery, item five, fiction. Okay, then let's define a new features. User likes many mystery books. Many in this definition is 0.66, 2/3 of the total purchase, or at least two books. So the user one, what is user one? He bought at least two books of mystery. Then the result is true. So we can say that, okay, user one is true, that he likes many mystery books. What about Alice? Alice bought item two, one, which is mystery, and she also bought item four, one, which is also mystery. Among those two items, can we say 2/3 of the total purchase? No, because Alice only bought two products. But Alice bought at least two books. So at least two books. The first book is item two, and the second book is item four, and both of them are mystery. So Alice like many mystery books. It is true. because it is true and this is true. Okay, we have a new features. So the new features, when user like many mystery books, the result is true for Alice and it is true for user one. Now let's look at these features. We set the user like some X book, some and many. It is different. If it is some, then it is 1/3. So you can define. Okay? You can define by yourself. 1/3 means 1 out of 3. Some bunyi itu. So requiring 1/3 of the user purchase or at least one item in absolute numbers. So if there is one item bought by the users, then it is some. So let's see. User liked some mystery books. So user two, he bought item 1, which is romance, item 2, which is mystery, and item 5, which is fiction. Okay. This user bought one mystery book. So the user liked some of the mystery book. So the user 2 is true. What about user 3? Item 1 is true, which is romance. Item 3, which is mystery. Okay. Then at least one item, because there is one item which is mystery. So user 3 is also true for some mystery books. And so on. So we can define again. User like many romance books. So many means 2 out of 3. Or there are there are at least 2 books. If you look at the data, okay, there are no users who are true for these features. Now we will look at this one. User like some romance book. Okay, we can see user 2 and user 3 here. And the other genre is fiction. So we can also create the feature for fiction. Now, from these features, because this is hybrid input features. And yeah, it actually turns out that user 2 behave in a very indeterminate or not exactly known manner by buying some books of all 3 genres. Okay, what does it mean? So we can see that user 2 they are in the 3 genres. User 2 like mystery, user 2 like romance, and user 2 also like fiction. So he or she like many books. Yeah. But if you look at the user 1, the user 1 like mystery and fiction. If you look at the user 3 like romance and mystery. User 4 like fiction book. So if you look at this one, when you use the similarity measures, if you use these similarity measures only based on the community knowledge, you will see that, okay, Alice user 1 and user 2 seems to be similar, but actually Alice is more similar only to user 1 in the aspect of the content. So in contrast, user 1 seems to focus specifically on the mystery books as Alice does. Hence, we can recommend user 1 items which the gender is mystery. That is item 3 to Alice. So if you want to recommend books to Alice, because we know that Alice only has a feature which is true on the mystery book, then you do not need to recommend item 1. You do not need to recommend item 5. you can recommend item 3 because Alice have not bought item 3. Alice only bought item 2 and item 4. Item 2 is mystery, item 4 is mystery, and item 3 is another mystery book. So this is how we can create the features combination. The feature augmentation. So the feature augmentation means we want to boost it. We want to boost the collaborative filtering, or we want to say this is the content boosted collaborative filtering. It is based on the content features, and we will have additional ratings. For example, Alice likes item 1 and 3. So it is unary ratings. You know, unary. Unary means single. Okay. So if item 7 is similar to 1 and 3 by a degree 0.75, then Alice will like the item 7 by 0.75. So we can make some kind of similarity, okay? And this one, we will need the item matrices, item matrix. And using this one, the matrix will become less sparse. And we can look at the weighting and some adjustment factors. If you still remember when we do with the community base, okay, pairs with more correlated items are more important. You know, correlated items. If Alice give item 1 rating 5, she also give rating 2 3, and then user 1 give rating 4 and this item 5, but user 2 didn't give any rating to item 1 and item 2, then we can say Alice and user 1 they are co-rated, okay, pairs with co-rated items. So because both of the users they give rating to the same items, we call co-rated items, pairs with co-rated items. Higher confidence in the content-based prediction if higher number of own ratings. So if it is higher, okay, then we have a higher confidence on this particular item. If we have a small rating, then we have a small confidence. So this is one of the works that has been proposed by Prem and Robert. So for example, let's look at the content boosted collaborative filtering. We have this numbers. It presents the examples of user item metrics. Rating values for item 5. So Alice, I want to know what is the rating on the item 5. For the user 1, he gave the rating 4. For the user 2, he gave the rating 2.2. And then we combine with other features. For example, we got the person correlation. You know, the person correlation. The person correlation from Alice with the particular user, okay, Alice and user 1 is 0.8. Alice and user 2 is 0.7. And then we want to check also the number of users ratings. So the number of users who gave the rating. So in this case, yeah, we have 40 means the Alice give 40 items rating. So 40 items has been rated by Alice. In this case, 14 items has been rated by user 1. in this case, 55 items has been rated by used to. And we want to check the numbers of overlapping ratings between Alice and other users. For example, here 6. It means there are 6 items where Alice and user 1 has the ratings. Overlapping ratings. So for example, if item 1, item 2, item 3, if we have Alice and user 1, if we have rating here, if we have rating here, and if we have rating here, then it means there are 3 items that are overlapping. So in this case, there are 6. And between Alice and user 2, there are 28. So it means they have more similarity, even though we do not know the difference between the ratings of user 2 and Alice. So using this data, we can create what we call as pseudo user rating. Do you know the meaning? Pseudo user rating. So it is a generated rating. Generated rating means we create a new rating based on these features. So the rating will be V. So this one, the pseudo user rating, is the prediction for the unrated items. It will be V. It is R if user U rated item I. So if there is a rating, then we will just use the rating. But if it is not available, then let's do the content-based prediction. So we will check with the C. Okay. Then we can just apply this computation. So the recommendation will be A, I. So we will check this one with V, which is the pseudo user rating, P, which is the person correlation, HW, which is the hybrid correlation weight, SG, which is the significant weighting factor, HM, which is the harmonic mean, SW is self-weighting factor, CAI is the content-based prediction. In this case, the researchers assume, okay, when the number of correlated items is greater than 50, the effect tends to level off. So if the number of correlated items is high, it means they are tending to be very similar. So they have the same interest. So if the NI is less than 50, we will do this formula. How many number of the correlated items divided by 50? So they claim that the maximum is 50. If there are more than 50, we will use the maximum. And the other kind of numbers, not the self-weighting factor, we have also another constant. Okay. Max will be set into 2. Okay. So there's another research that they claim that we can just set 2 for this maximum. A is the respective user, I is the item, and U is the user. So A, let's say A is Alice, U is another user, and I is the item. So we can have the hybrid correlation with the featured augmentation like this one. The hybrid correlation width that is defined as follow. The HW is the summation of SG plus HM. SG is from this one. If it is higher than 50, then it is 1. If it is lower than 50, we will divide the number of correlated items of user Alice or A with another user divided by 50. It's M. It's M A comma U means 2 multiplied by MA MU divided by MA plus MU. Okay, so we will check this one. After you have this HW, you can put this HW here. You can put the HW here. And then we can do the recommendation of the Alice in the item I. So for example, we can get the MA is 40, yeah, 40 here, divided by 50. So 50 is the maximum number that the researchers claim it is the maximum. Okay. And the MA is 0.28. So this is from Alice. MU1. MU1 means the user 1. We have 14. So 14 divided by 50, it is 0.28. And MU2, we have 50. So 50, oh, sorry, 55. 55 divided by 50, it is more than 1. So we use the maximum, which is 1. So HM. What is HM? Based on the formula, okay, HM is SGAU plus HM. Oh, sorry. HM is this one. 2 multiplied by MAMU divided by MA plus MU. So we use this formula. 2 multiplied by MA MU, in this case user 1, divided by MA plus MU1. And for the HMAU2, 2 multiplied by A user 1 divided by MA plus M user 2. So we get this one and this one. The same with the previous one, we can calculate the SG. So SG means the number of correlated items. Okay. This is the number of correlated items divided by 50. The number of correlated items, which is 6, divided by 50. The number of correlated items divided by 50. So we get this number. And last, we will calculate the HW. The HW is the SG plus HM. So SG is from this one, and HM is from this one. Then we can get the value, maybe about around this one. And for the HWA user 2, we get the value here for 0.56, and then we got the value here for 0.88. Then we can get the value 1.45. Okay, so we got all those values. After we got these values, then okay, using this recommendation formula. So assuming that the content-based prediction for item 5 is C Alice, comma item 5 equals to 3. So we just assume, okay. So the content-based prediction, you can use like the content-based filtering. In the content-based filtering, you can get a numbers. So let's assume that the number is 3. Then we can calculate using this formula. SW, so SWA multiplied by CAI, which is 3. Okay. And then we do the summation. The summation for all, in this case, the HW is 0.535 multiplied by the percent correlation. multiply by 4. This is the rating for item 5 on these respective users, and plus 1.45 multiply by 0.7. 0.7 is the person similarity multiply by the rating given by user 2 on the item 5. So we divide with 1.6 plus this one. This is 0.5535 from here, multiply by the person correlation plus 1.45 multiply by 0.7, which is from the person correlation. So let's, because I mentioned to you, assume that the content-based prediction of Alice on item 5 is 3. So we can compare to user 1 who gave rating 4 to item 5. So user 1 give rating 4 to item 5. Alice is not euphoric on item 5. Okay, because the rating prediction is 2.87. So we call this is the collaborative content-based collaborative filtering, CBCF. CBCF is content boosted collaborative filtering. This is CBCF. User 2 has more influence to Alice based on the weighting and adjustment factors. Okay. So user 1 has only 0.5 contributing to the rating for Alice. But user 2 has 1.45. So it means the weight is more on the user 2 rather than user 1. Maybe because of here the information from user 2 give many rating to the users, to the items, and there are many ratings that are overlapping with Alice. So that's why user 2 contributes more on the rating for Alice. Okay, so that's the thing. Let's have a break. Okay, I will continue after the break.